Thanks for joining me in Hamburg. It's actually, like, I love this city. It's super beautiful, and it's my first time in Germany, so really excited to be here. My name's Rhea Bhatia. I'm part of the Azure team, so within Microsoft, part of the Azure Containers team. I'm one of the PMs, and I specifically work on our, I guess, serverless containers experience dash line of products, specifically virtual Kubelet. So I'm one of the maintainers on the project with some other people, some awesome people in the team, and then just around the community in general. How many of you guys have heard of virtual Kubelet? Okay, so we're actually doing a good job of like trying to teach people kind of. How many people know what it actually does, or you're here to learn that? Okay, that's awesome. So you've heard of it. So we're really good at PR, but we're not really good at teaching people yet. That's totally fine, because it's literally just been me that's been doing that. I've been the one that's been trying to spread the word about this project, and basically, the more people I talk to, the more developers we get on the project. And that's really why I do this, is because we just want more people to contribute, but we also want more people to understand and eventually use it. One thing I'll say is don't use it right now. Don't use it in production. Oh my God, I will have a heart attack if you try and use this in production. This is experimental. This is us trying to figure out what the future is, and so please don't do it. So hopefully that was a good introduction into what you're about to learn about. But before we get into virtual Kubelet, I need to talk a little bit about containers. And sometimes that you just need to run a container in the cloud. You don't really need a VM. You just kind of run it. You just want to run an image. You just want to get your Nginx container up. And that's why Microsoft, about a year ago now, came out with a service called Azure Container Instances. And it was the first time in all of the clouds that you were able to just push up a container, see it running, and then it would spin down when your workload was done or when your image was done executing. And the coolest part about it was it starts in seconds. And the way that we were building this product is it's a true form of compute. It's a primitive, just like a VM is. So we want you to take this as a layer of infrastructure. That's all it is. It's never going to have an orchestrator on top of it. You're never going to be able to scale ACI. And you get billed per second. So that's kind of the basis of what we need to understand. And all the marketing terms you're going to hear about this is serverless containers. But the way that we actually want to talk about it is pods as a service or containers as a service. That's the way that you would utilize this. Just like you would utilize probably a VM as a service, an IaaS. This is now a different word for a PaaS or CaaS or whatever, if you take the abbreviations. Another thing is there's hypervisor isolation. So what that means is in our infrastructure, we might be multi-tenant, we might not be, but that doesn't matter to you. Your container can't be touched by anyone else's container, so you're completely isolated from anyone else. And we have Linux and Windows, so if you're running Windows workloads, you're good. But probably most of you guys are running Linux ones, so you're good there too. So I would just encourage you guys to try it out, spin it up, spin it down. Thankfully, it's really easy to use, and that's the whole point of the service. If you're just getting started with containers, if you're just trying to figure out how do I create my first Docker file, how do I run this in the cloud, this is a really good starting point. But it's probably not all you're going to need. And especially here at Container Days, a lot of us have been talking about Kubernetes and things like that. So we're going to be talking about how we can actually mesh this with Kubernetes and change the way that you interact with Kubernetes itself and the primitives you interact with. Okay, slide to tell you about, there's a lot of random words in this industry right now. There's functions as a service, there's containers as a service, there's serverless containers. And basically what I'm trying to say is, you might hear these three terms, and that's what we're talking about. It's a core level of infrastructure. We still need, there's a long way to go to actually make it true serverless. We still have a long way to go, but this is the starting point. And our point is, if you're already creating containers, like your workloads for containers, if you're developing in containers, why do you need to touch anything else? Why do you need to manage a VM if you're already creating something in a container? So if you guys are asking yourselves those questions on why you have to do updates, why you have to do upgrades in Kubernetes, things like that, those are the questions we're attempting to answer with this service, and we're attempting to answer with virtual Kubelet. So also, I have to do a tagline because I'm part of Microsoft and we always have to do this stuff. So Azure Kubernetes Service, AKS, it's GA. It's our Kubernetes, our managed Kubernetes service. And the experience within AKS is probably one of the best out of all the cloud providers because we're building it and we're the ones leading this whole serverless containers initiative right now. So within AKS, if you spin up this cluster, you'll be able to get all of the goodness that I'm about to talk about. But you can use this in any cloud. You can use this on any cluster. If you have a Minikube cluster, this will work for you. And I know I haven't explained what this is yet, so we're about to get there. But the point is, we have managed Kubernetes. You get your own kube config. You spin it up in literally 2 commands. It's AZ AKS create. You get to decide how many nodes you want. So it's actually a pretty simple setup process. And then after that, it's really up to you to actually deploy your workloads to it and do whatever else you want. But just know it's managed. We also have no cost for the service at all. You are only paying for the VMs, and that's it. So it's basically like getting a VM in Azure, same price. And you can spin down to at least 1 node. So upstream Kubernetes, we don't pay for it. One really cool thing about this product is we actually developed this in the open. So any features that we release are actually going through a project called ACS Engine first. So you can see all the features that our developers are working on. You can actually contribute if you want to. That'd be a little strange, but you totally can. And everything that comes out in ACS Engine gets pulled in by AKS. So our entire product's open source. And that's something that's probably really good to hear because with confidence you can see, you can even track our features and you can see what bugs we're working on. You can add an issue if you want. So it's just in the Azure repo, ACS Engine. Okay, now we're gonna get to the fun stuff I like talking about. So about a year ago, when we released Azure Container Instances, we also released something called the ACI connector. And I know that doesn't look like this word up here, but what it meant to show was that ACI itself is never gonna scale. It's never gonna have service discovery. It's never gonna have all of the goodness that Kubernetes does. But with the ACI connector, you can now connect in your pods as a service platform to Kubernetes itself. So if you start to think about what that looks like, you basically have your managed cluster, which is effectively managed nodes, and we help you with updates and upgrades and stuff like that. But it's still not managed agents. You still have your agents in your subscription. You still hold them. They're still up to you for how you utilize them. And that's what we're trying to change with this. So we came out with the ACI connector, and we're like, this is an explicit move. This is to show the community that you're not, pods as a service isn't meant to, on its own, be its own form of an orchestrator. You're supposed to connect it into Kubernetes because Kubernetes is the orchestrator, and that's what we're all conforming to right now. So what we're trying to say with the ACI connector is connect it into Kubernetes. And I'll also give you some background on what's going on in the community and why we kind of say it like that. The architecture of it. So virtual kubelet is literally a virtual kubelet. So we came out with the ACI connector. It was written in TypeScript because Brendan Burns wanted to learn TypeScript. So, and then I joined the team, and I was like, what is this? What is all these things? And then about a couple months after I joined, we finally got some more development support. We got it from the CDA team within Microsoft, and we started to create this community within Microsoft itself, a community of open source developers that weren't part of the product team, that wanted to contribute to cool projects. And that's actually how this project is surviving today. We're not using anyone from the product team. I have a 0.25 of an engineer in the product team. It's actually a community within Microsoft that we've created and a community that we're starting to create within the actual open source community. So that's a really cool background on what's been going on. But the way that it works, and this is how the ACI connector worked too, it creates a fake node or a fakelet. We're really reproducing the Kubelet APIs, and it's really just a translator into the Kubernetes APIs to our APIs, and that's all we did. And then we rebranded it as Virtual Kubelet because we also created a pluggable infrastructure. So a pluggable interface, I should say. So if you have a pods as a service platform, you can also create your own virtual kubelet provider. And now you can connect it into any Kubernetes cluster, and people can start spinning out pods to your service. But anyone can be a provider. And this is something that we're also struggling with. What does it mean to be a provider for virtual kubelet? If you can create a pod and you put some random code behind it, if you can delete a pod and put some random code, if you can update a pod, then you can be a provider into virtual kubelet. So people are trying to, someone created a silly provider, Liz Rice, you can look it up. She created one, and it really doesn't do much, but it's a really easy implementation of how you guys could create your own provider if you want. For example, if you want to create a pod and connect it to a light, you could say kubectl and like create the pod, and the light would turn on in Kubernetes. That's what the provider would do for you. And in your pod spec, you would basically say that you wanted to ship it out to that node. So that's what you would end up doing. That's how it works. It looks like a fake node, so you interact with it like it is a node, but it's not. And that may be a little bit strange. We're trying to like get away from nodes, but we're also faking out a node, so then you can deploy into ACI. But you don't have to do you don't have to manage that node. That node is effectively managed by us, and that's it. That's all you do. So that's architecture. If you want to go to our GitHub repo, you can get our first README is all about how to contribute, all about how to develop for the project. Once you get into the providers, that's when you get into, as a customer, how would you use all of this stuff? So scenarios. Why did we build it? What is this for? It's really for this unlimited form of compute, and it's for operators. It's for people that don't want to manage more infrastructure. We're trying to slowly in the community, we have Kubernetes, and I think we've all decided that it is a little bit too difficult to use. And this is our attempt in Azure to be like, how do we get more above the forms of compute? How do we continue to abstract above VMs and continue to abstract above containers? So this is only one step. And what I'm trying to say is, in about 5 years, like, we shouldn't even be looking at Kubernetes, right? Like, we shouldn't have to deal with that. We should just deploy code. What all of your guys' businesses are trying to do is solve an actual customer use case. So why do you need to solve these problems? We should be solving that for you. And that's really the point of our team and what we're trying to do. So some use cases of what you can do today with virtual kubelet. You can start bursting out. So today you still have to have VMs in your cluster. We haven't created a nodeless or a zero node Kubernetes cluster yet. We're actually working on it. But basically, you'll have your nodes. This is your managed control plane. And then you install the ACI connector. It looks like a node in your cluster. And whenever you spin out to that node, you just spin out pods. So now you don't have to think about how many pods are in a node. How do I manage this node? What if it goes down? Things like that. You just look at it from the pod perspective. If it goes down, it's going to move over, right? Kubernetes will attempt to move it over to a different pod, but this isn't going to go down. That's our infrastructure. In our backend, we're failing over things. We'll move things over. But so you guys can be confident that when you're spinning out a pod, you're actually spinning out a pod. And managing VMs completely goes away. So I'll give you an example for an actual customer that was thinking about how they would use this in their infra. So they're a meter reading company, so they're reading meters from everywhere, trying to figure out if you have power and what wattage and things like that is going to you. So say if there's a natural disaster, suddenly everyone's power goes out and they have to read millions of meters. They need to figure out what's going on and they need to help out and things like that. So suddenly they have a burst in traffic. If you have a burst in traffic, that means you have to over-provision your clusters right now so you're ready for that natural disaster. And or you can use the Kubernetes autoscaler. It's still going to continue to create a node and then create another node and create another node. And that will take a little while. For this, there's no node creation. There's just pod creation. And these are already pre-provisioned. So they're going to spin up very fast. And that's where, instead of over-provisioning and spending all that money for VMs, you could just spin out pods when you need them. They're there, and then they'll spin down when they're done. And it's also way cheaper. And when you look at, for example, if you're doing ML workloads and you have a bunch of GPUs are really expensive. They're expensive in all the cloud providers. So you can start to think of interesting configurations where if you need a GPU workload, you can spin that out in ACI or in any cloud as a platform, pods as a platform service, and you'll be billed per second. So it's way cheaper than getting an actual machine with 4 cores with GPUs and all, like GPU enabled. It's way less expensive because then it'll spin down and so you're saving money. So stop using compute, stop over-provisioning compute that you don't need. And I'm sure you guys have also, like, in your dev clusters and your test clusters, you just have clusters lying around, right? Probably, with just nodes kind of sitting there. You're paying for that if you're in a cloud provider, and so instead of doing that, you could also just have this 0-node cluster or a 1-node cluster, and then you can start to spin out pods. when you need them. It's just on-demand compute. Okay. Also, yeah, this the waste is also supposed to show people leave a little bit of slack in VMs too today. That also gets eliminated with ACI. You're not wasting resources anymore. Another thing I didn't mention is ACI is configurable by the amount of compute resources you need. So if you need 4 cores, if you need 1 core, you can get that. You ask for that resource, and we say, okay, so now you can get as much memory as you need and as much CPU usage, CPU power as you need. Okay. So virtual kubelet, this is the repo. Our contributors have, this is actually a little while ago I took this picture, but we have a lot more contributors now. I would encourage you guys to look at this repo, look at what's going on, look at the features. Everything we do is from this repo. And if you go to providers, this is where I'll talk about, you can see AWS Fargate. We're working with a bunch of different people, players in the space. So I like to say my role in Microsoft is half Azure, but it's really like now 50, 60% open source. What I'm doing and what we're trying to do is conform as a community on what this means. Because Microsoft isn't going to go in a black hole and figure it out on our own. We're going to ask you guys, and we're going to talk to everyone and figure it out as a community. So we have virtual Kubelet meetings every Wednesday at 3, not this week because I'm abroad. But we have virtual Kubelet meetings, and we talk with VMware, with Amazon, with Hyper, with anyone else who's interested in the project and interested in how they would use it. So VMware has a VIC provider in here too. So if you guys are using vSphere, go for it, use it. There's also an IoT edge implementation. So if you guys have IoT workloads, you can start to deploy and manage your IoT workloads from Kubernetes. That's interesting, right? Like, maybe you can all deploy it from one place. Another thing is, with each connector, you can have a different configuration. So with each virtual kubelet, it could spin out to a different region. They could spin out to different clouds. If you have a virtual kubelet from Amazon and a virtual kubelet from Azure, they could spin out to different clouds in the same resource group, or in this, sorry, not resource group, in the same cluster. Resource group is an Azure thing, so don't worry about it. But you can also have different connectors for, say, GPU-enabled container instances. So now your configurations get really interesting. But networking will not work. We cannot network across clouds yet, and we haven't figured that out. So like your in-house normal networking will not work. So just know that. Also today, virtual kubelet is limited. We can't create services that are backed by any pods in virtual kubelet because we haven't created that in virtual kubelet itself. All of the APIs that go into virtual kubelet, we have to create, and that just, we have to do it. We've done a couple. So for example, you can, there's a PR right now out for kubectl exec to exec in your containers. There's also kubectl logs out. The experience isn't the best right now. So these are all the things we have to fix. But you can create a pod, you can delete it, you can start it up, and you can also do batch workloads. So if you need to do a lot of processing on data, you can do that today with virtual kubelet, and you can just spin out into ACI and spin down. Provider definition. So this is we are trying to figure out what a provider means and what it should be, and this is basically what we've boiled it down to. You need to provide the backend plumbing. So there's an interface in the virtual kubelet repo. If you can complete those tasks, basically, you can be a provider. And then conform to the API provided by virtual kubelet, basically the same thing. And have access to the Kubernetes API server and a well-defined callback mechanism for getting data like secrets or config maps. So it's actually pretty simple. I'm sure if you guys spend a day, you guys could create your own provider, and it could literally do anything you want. It also doesn't have to be housed in our repo, so go crazy, I would say. This is giving you an abstraction into Kubernetes. There's also different orchestrators out there. We could create abstractions of into different orchestrators from virtual kubelet, which we've actually done within Microsoft. We just haven't released it because it's a little bit confusing. So think about this. Think about what you could build. Think about how it could help you just manage everything from one place, because it really is just an interface. And that's what the project is at its core. It's just an interface. What we're trying to do is make serverless containers a thing. We're trying to eliminate the need for nodes completely, but it really could have a bunch of other use cases. We think it's bigger than what we just built. We think it's bigger than our one use case, and that's where why we're coming out and talking to you guys, because we want you to figure out what are the other ones. How else can we make Kubernetes more flexible for your infrastructures? So how do we do it? And I kind of already touched on this and how we built a community within Microsoft, but we've also built a community just around the community in general. So I have AWS out there. Any AWS people out there in the crowd? Yeah, one? Okay, cool. Hello, friend. So yeah, I work with AWS every day. So they just launched EKS. Woo, congrats. And everyone speaking up there I've talked to personally because they're invested in this project, which is pretty awesome. So this kind of gives a lot of the cloud providers just an outlet where we can work together. And that's what Kubernetes did from the start. It was an outlet for where we could work together. And it's still pretty new. We're still not ramping up to where we want to be yet for how many contributors we have to Kubernetes in general. And same with this project. This project right now is literally maintained by Microsoft people, but if you look at the actual people in our organization, they're from everywhere. And we're talking to everyone about it, and we're building architectures with them. So yeah, and also customers, so WebJet. People are really loving this project. It gives them confidence that we're not just going to go back to the old Microsoft and hide in a corner and build stuff and then release it. We're going to actually build innovative products in the open, and that's how we're going to do it. This is one of our most strategic things that we have within our platform today. And I can stand up here and tell you guys that, and that's okay. That's very different from probably a couple years ago. Yeah. Okay. Fun stuff. So control loops. I'm going to step back here so I stop looking behind me. This is currently the Couplet function control loops, and we have some asynchronous and synchronous control loops here. This is what the Kubelet does today. It does all the things that you're probably used to, getting logs, pulling the image, creating events, updating, deleting, getting this pod status and node status. For example, getting node status, how would you, so if we're in our data center, right, how do we push back node status when there's no node? Right now, we're pushing random values. So if you install Virtual Kubelet and you look at it, it's going to be completely random. It's not actually the node status. But what do we do? Do we actually show you how much capacity we have in our data center? Do we give you, like, this is how much CPU usage you can use? That's probably a little bit insane. We probably shouldn't do that as a security risk, because then someone could DDoS us. Also, if you try and DDoS us, we will throttle you at 20 container instances. So if you're trying to do more than 20, you have to talk to our engineers, and we'll pull you up, just because it's a new service and we have clusters all over the world. Just keep that in note if you're trying to use this in production. So you actually can't do that, but yeah. Let's forward that. This is what we have today. That's not a lot at all, right? Like, there's nothing up here. How is this project surviving? It's because you can do the basic stuff. You can create a pod, you can delete a pod, you can get an image. So you can create one, you can do work, you can do workloads. And I'll show you one today. I'm going to show you a Tensorflow demo where I'm doing work, where I'm processing pictures and I'm finding different fruits and matching them to emojis. But say if you're trying to find faces, if you have a big data set and you're trying to find all the faces in all those pictures, you can do that today with ACI2, with Virtual Kubelet. It will spin out for you, and you don't have to spin out that much compute in your own cluster. This is what we think we need to get to. So some things that are missing, you will never have access to the host in these services. That's what we've explicitly said. You do not have any host access, so you cannot do a Docker build. You can't do daemon sets either. That's something that we've decided as a community. If you feel like it's different, please talk to us, because it was literally me and Amazon, VMware all sitting together in a room in Redmond, which is also weird, right? Like, the people that created EKS were sitting with me at a table, and I'm also part of the team that creates AKS. I just think these are like just funny to me, that we can work together in these things. But yeah, so we have a lot to do. So if you want to contribute, please do. Please contribute. I will send you Virtual Kubelet shirts. I will do everything that you want. But yeah, but also create your own providers for what you want. We have a release schedule on the 15th. Whether we follow that is a little iffy, but we just cut out a new release last night. It was .4. I know that wasn't on the 15th. We were like a couple days late, but we were early for the last one. So once we get an actual cadence, once this is production ready, we'll actually have a regular cadence of the 15th. We might change it to like every other week depending on development and stuff. But we do have a cadence. We do have some governance going on. Things that that's in the roadmap. So these are the things that we plan to implement. And I put our companies on there because this is what they have signed up to do. It's open source, so I have no power over any of this. I wish I did. But exec is out there. There's a PR. Attach we haven't done yet. Or port forwarding. We're not sure why we need it completely yet from an ACI standpoint. Service creation is huge. We need to understand how to create services. And if you look at services today, we use IP tables, we use kubeproxy and things like that. In a just container world, where do those sit? You don't have access to the host anymore. You can't access that at all. So the designs that we're coming up with for how we're going to enable you guys to do this in your own infrastructure with like private VNet is really interesting. I think these networking things are going to be really cool. So what we are thinking about, say if you go down to 0 nodes, because 0 nodes is going to be a reality, then you have no VM, you have no host, so what do you do? How do you route to things without a kubeproxy? We might actually run that in ACI itself. So then the ACI pods can talk back to the cluster. Right now we figured out that the cluster, your services can talk the other way, they can talk to ACI, but ACI doesn't know how to route back to the cluster. So that's what we have to figure out. And that's what we're actually designing today and right now. We also need to implement this within the service, within Virtual Kubelet. But Virtual Kubelet is just actually passing values. It's not going to do anything else. It's just really going to be that interface. We just have to create that interface. The real work comes down to the provider. But then you get into this stance. Now are we giving too much power to the providers? And now do we have to govern over how the provider implements this in their own infrastructure? Do I have to go into Amazon's infrastructure and look at how they're going to implement kubeproxy and make sure that's like conformant? I don't know. There's a lot of unanswered questions right now because this is really early days for this project. Did I go through all of this? Out of tree, we're thinking of making Virtual Kubelet into a library instead of its actual what it is today. Don't know. We might just like try it for a little while, see if it doesn't work and find out why, and then roll back if it doesn't. And then we need to put tests in there. Let's see, admission controllers. So we might create our own admission controller for pods as a service too. That's also a thought. We might have to change the way orchestration works slightly, but the reason we're doing this and we're saying this now is we're going to work with the community, so it doesn't change the way you guys work today. It's going to be the same. The way you interact with Virtual Kubelet today is exactly the same as, you don't have to learn anything new. And I'll go through that too. Okay. And this is where I go into Azure. So we still have the ACI connector. Virtual Kubelet is the implementation details behind it, but as a customer, you would really just need to know about the ACI connector. That's what's in our docs. ACI connector is our implementation of Virtual Kubelet, and it allows you to connect out to Azure container instances. So it gives you the Kubernetes orchestration power, the infinite scale of our data centers, and you install it with literally command. I know I put 4 commands up here, but it's actually it's one. It's just 4 different ways you can do it. So if you want a Linux connector, you can say Linux. Also, the default is Linux, so you don't even have to specify that. Last week, we released a PR or released a new command where you don't have to specify the connector name anymore. So you do have to specify the AKS cluster you're running on, so the cluster name, and then your resource group. Resource groups are how Azure groups together different resources. So if you have like a cluster and then you have like a volume in there, those are all could be within the same resource group, but it's your logical mapping of how projects work. So that's all you would do. It's actually so simple to start this. 5 minutes, okay. Things that we're looking for the future. So we have features for Virtual Kubelet itself, core, and then we also have features for the ACI connector for Azure's experience. Azure's experience is pretty awesome. It's really easy to use, thankfully. We already have upgrade connector. You can scale down to 0 node cluster. We want to scale down to 0 node clusters in AKS. There's a working group, PR out there, that we're going to make a working group for nodeless. Join us. We have a Slack channel. I'm going fast because I want to show you a demo. And then the working group for Nodeless, it isn't out there yet, and it's not. It hasn't been approved. If you really want to laugh today, or if you really want to see what's going on in the community, go on that page. See all the comments. And this is what, it's just a struggle because this is the first time the community hasn't decided that this is the right way to go yet. And that's okay. And I think it's okay if different providers want to do different things. And that's just the reality we live in. Like, Kubernetes is growing, and that's totally fine. So look at and see how we're trying to like interact with the community to make this happen. But everyone's great. Love Google, love Amazon, love Microsoft. Everyone's awesome. Okay, so now we're going to go to a TensorFlow bursting demo. So I'm actually going to show you how this all works together, because I think that will really harden in your minds, like, what do I do with this as a user today? Okay, so I'm going to get my nodes. I'm running in Azure right now. I have a 2-node cluster, and I also have the virtual kubelet already installed. See if this, the Wi-Fi has been very shady today. So it worked when I was in there. We'll see if I'm connected. I'm also at 26%. But basically, it's going to come up one day. There we go. Okay, so I have my 2 nodes. I also have my virtual kubelet. Looks like a node, exactly what I told you guys before. Don't worry about the version. For virtual kubelet, it's a string that gets passed. So don't worry about it. One day we will actually go off the Kubernetes versions, okay? But not today. So I'm going to use Helm to install an entire facial recognition demo. So it's called TensorStuff. And yeah, it's using TensorFlow, and it's just processing pictures, as I said before. So there it goes. Helm is a really easy way to package up applications and deploy them. So I have 2 services. I have some pods. I have deployments, and they're all packaged up in Helm charts. And this is how I make sure I don't have to pray to the demo gods ever, unless it's for Wi-Fi, because it works the same every single time, because I already configured everything. So there we go. We're going to tap the UI. But before we tap it, I'm actually just going to scale up right now because I don't have a lot of time. Deploy. And I'm scaling up this ACI deployment, and I'll show you what that looks like. 10. So before those start up, let's tap the UI. Okay, so it's up and running. This is on my cluster. It's going to go through pictures, and it's going to go pretty slowly. It's going to go at about 1 image per second, which is kind of slow. There's about 2 workers in there. And if I go ahead, oh, it still hasn't come back. Okay. If I go ahead and get pods, you're going to see that I just scaled up my ACI deployment. So what just happened was I scaled up into ACI itself. It's not in my cluster. I would have had to start probably 2 more nodes for all of these pods. I didn't have to do that. I just scaled. That's all I thought about, which is pretty awesome. So we're going to get pods. Interwebs. Let's do it. There we go. Okay. So they're waiting. They're pending. That's good. I'm going to go and say wide so you can see that they're on that weird node and not actually in my cluster at all. And we might see them start to spike out a little bit soon. Starting, I think one of them started. Woot. It's going to the East US because all my clusters are in the United States. You can do this in Europe too. I probably should have repaved this in Europe. But you can see that they're all getting public IPs, not internal IPs, because this isn't a different service. And with ACI, we automatically provision you public IPs unless you don't ask for it. And then AKS right here. They're waiting, probably because they're trying to get over the sea. 12 workers. Oh, they're already up. Okay, so that was fast. They're working. This is all ACI. This is a completely different service. This isn't in my cluster. It's processing work. And literally after this, I'm going to spin it down, and it was way cheaper than just over-provisioning my cluster and waiting there for that compute. Because if I tried to scale this now, it would have taken way longer, and I would have gone over time. So thank you. Do I have time for a question? 2 minutes? Okay, I have time for like 1 question, maybe 2. That was a lot of info, I know. Oh, am I supposed to throw this? Okay. Should I throw it? I saw people doing that, and I was like, I want to do that. Okay, you got it.
Okay, So you talked about the resource limits. You can limit the resources in ACI. You can limit them with pods. Does this reflection work? If I said the pod's resource limit, is this reflected in ACI?
Yeah.
If I say I want a 2 gig
Yep,
pod?
it all gets, so yeah, anything in your pod spec gets flown through the ACI. So I actually have a volume mount. I have, can I show you all of this? Oh, my thing's not up right now. That sucks. Let me go into ACI itself. Let me show you the GitHub repo. Everything's the same. You interact with this the same way you do in Kubernetes. Nothing's different, except we have a taint, we have a toleration in there, and a key that you have to put in, and a label, a node selector. Only difference. Everything else is the same. So user experience should be great for you.
You spin up everything on public IP address. Are there any access control in place?
So you can also say that you don't want a public IP. Like right now I'm specifying that I want a public IP. You can also say that you don't. And then it just won't be accessible to anyone, and it'll just outdo the data output and then output it somewhere. We will have VNet, a private preview next month in July, so literally 2 weeks. And then we'll public preview it. But right now we don't have VNet, so eventually you'll be okay. AKS has VNet though, so. Okay. So talk to me afterwards if you have any questions. I'm also on Twitter. I'm everywhere. So feel free to talk to me if you want to contribute, if you want to be a customer or a provider into Virtual Kubelet. I don't care if you're on Amazon or VMware or wherever. Like, I'm an open source PM now, so it doesn't matter. But thank you. Thank you for listening. Hopefully this was informal.